Sir. Okay. Okay. So, this is again a tutorial lecture 8. Now, here we will discuss few problems based on the continuity. So, first check the continuity of the function f x at x equal to 0, where f x is 1 plus 2 x raised to the power 1 by x, and x is not equal to 0 and 0 otherwise. Okay. So, solution, we want the check the continuity. What is the meaning of continuity? A function f x is said to be continuous at a point x equal to x naught if the limit of this function f x when x tends to x naught is f x naught. It means the limit exists and must be equal to the value of the function at a point x naught. So, when we say the limit exists, the left hand limit and the right hand limit must be the same and it should be equal to the functional value at the point x naught. If any one of them fails, then we say if the left hand limit and right limit are not same, then function will not be continuous, or even if the limit exists, but it differs from the f x naught, then also it will not be a continuous function. So, in order to justify or to show check whether this function is a continuous function or not, we will consider the left and right hand limit and then see both are equal to the value of the function at a point 0. So, let us take here we will use this result. We know this result is limit h tends to 0 1 plus a h raised to the power 1 by h is equal to e to the power a. So, this result we will make use of this. Okay. So, let us consider the function limit of the function f x when x tends to 0 plus f x. So, this is equal to limit x tends to 0 plus means 0 plus h 0 plus f x means 1 plus 2 x raised to the power 1 by x. Put x equal to 0 plus h. So, this is the limit h tends to 0 1 plus 2 h raised to the power 1 by h, and according to this it will be e 2. Then left hand limit f x when x tends to 0 minus, this is the same as limit x tends to 0 minus 1 plus 2 x raised to the power 1 by x, and here put x equal to 0 minus h. So, limit h tends to 0 1 minus 2 x 2 h 1 minus 2 h divided by minus 1 by minus h. So, if we look this one, then this is the same as minus h is p. So, limit p tends to 0 1 plus 2 p divided by 1 by p, where p is minus h, and this limit is also coming to be e 2, which is the same as the functional value. So, what we see here is that, so this shows limit f x when x tends to 0 minus is the same as the limit f x when x tends to 0 plus is the same as is not equal to f of 0. Therefore, the function is not continuous. The function f is not continuous at 0 at x equal to 0. However, if I replace 0 value by e square, the function will be continuous, is it not? So, it will be like this. Is it okay? Not continuous for this. Okay. Next exercise. Find the values of a and b for which the function f x equal to minus 2 sin x when x lies between minus pi less than equal to x less than equal to minus pi by 2, a sin x plus b when minus pi by 2 is strictly less than x is strictly less than pi by 2 and equal to cosine x if pi x lies between pi by 2 less than equal to x less than pi. So, between minus pi to pi the function f x is defined in this way. Okay. Find the value of this for which the function this is continuous. Throughout continuous. So, basically these are the breaking points. This is minus pi, here 0, this is minus pi by 2, here pi by 2 and this is pi. So, between minus pi by 2 to pi means minus pi by 2 pi, in this interval the function is defined in some this way, and from minus pi by 2 to pi by 2 in this function the function is defined in this way, while pi by 2 minus pi by 2 the function is defined in this way. So, basically the three ways the function is defined. If we look the function in the interval minus pi by pi to minus pi by 2, it is a sine function. It is definitely continuous and differentiable. Minus pi by 2 again a sin x plus b again is a continuous and differentiable except at the end points, which we do not know whether it is continuous or not. Similarly, cosine function is a continuous function within this range open interval pi by 2 and pi, but at the end point it has the point of continuity or maybe discontinuity that we have to test. But since it is asked to find the value of a and b so that the function is continuous, it means at the end point from the left hand side and the right hand side the value of the function must be attain the same limit and must be the value of the function at that point. So, we will basically discuss the continuity of the function at a point minus pi by 2 at the point pi by 2 like this. So, imposing the restriction the function is also continuous at minus pi by 2 and pi by 2, we will get the three equations which can be solved and find the value of a and b. So, let us say first what is the value of the function at a point minus pi by 2. The value of the function at a point minus pi by 2 is minus 2 sin x at x equal to minus pi by 2. So, that is equal to 2, because sin minus pi means minus sin pi by 2. So, this and the value of the function at a point pi by 2 can be obtained from here. So, this is the cosine of x and pi by 2, this is comes out to be 0. Okay. Now, let us see the limiting value. What will be the f of at x equal to minus pi by 2 continuity. So, take the functional value minus 0, that is limit of the function f x when x approaches to minus pi by 2 from the negative side, from the left hand side. So, this is the same as limit h tends to 0 f of minus pi by 2 minus h when h approaches to 0, and this will be the same as limit h tends to 0 minus pi by 2 minus h lies here. So, it is minus 2 sin minus pi by 2 minus h. This is our, and finally, when you go for this, the limit will come out to be 2, because minus minus outside 2 times sin pi by 2 plus h, and that becomes the cos of h tends to 0. So, this becomes the 2 times of cos h tends to 0. So, this is 2. Okay. So, we are getting this left hand values limit is 2. Now, let us see the right hand limit. The right hand limit is f pi by 2 plus 0 minus pi by 2 plus 0, that is equal to limit h tends to 0 f of minus pi by 2 plus h, and that will be equal to limit h tends to 0 a pi by minus pi by 2 plus h is given by this formula. Within this range, the function is defined in this way. So, a times sin x, a times sin x. So, minus pi by 2 plus h and then plus b, and when you simplify it, the value will come out to minus a plus b, because this is minus a sin pi by 2 minus h is cosine h, and cosine h is h tends to 0 is 1. So, minus a and plus b. But since f x is continuous, so the value of the function minus pi by 2 minus h, limiting value from the right and left hand side, and the value of the function at a minus pi 2 must be identical, and this implies minus a plus b equal to 2. So, let is 1. Now, second part, at x equal to pi by 2. Again we have to see continuity. So, f of pi by 2 minus 0, limit h tends to 0, f of pi by 2 minus h, but pi by 2 minus h, this is defined by a sin x plus b. So, it will come out to be the limit h tends to 0, a sin pi by 2 minus h plus b, and when we simplify, it comes out to a plus b. Okay. So, pi by 2 minus h, and then now pi by 2 plus h we will see. So, f of pi by 2 plus 0, h tends to 0, f of pi by 2 plus h, and this is given by cosine in this interval. So, cosine of pi by 2 plus h, that is of sin h, h tends to 0, and that comes out to be 0. Therefore, equating this, f of pi by 2 minus 0, f of pi by 2 plus 0, f of pi by 2, since f is continuous at x equal to pi by 2. So, we get this, and this implies a plus b is 0. So, solving 1 and 2, we get a is minus 1, b is 1. So, that will be the answer. Okay. So, that way we can find out this. Okay. Okay. Next question is, check the continuity of the function. Check the continuity of the function f x equal to x minus mod x by x, where the x belongs to R. So, here we will see that continuity of the function in general, whatever the point may be. So, let us see when x is positive, x is negative. These two things we will see, because when x is positive, the function f x is 0. When x is negative, the function is, when x is negative, the function is x minus x divided by x, that is equal to 2. Okay. So, basically the function is getting all throughout 0, and then all of a sudden it has a jump, sorry, it is opposite way, x is negative, it is 2, and then x is positive, it is a. So, at the point 0, the continuity of the function is breaked. Therefore, function is continuous everywhere except x equal to 0, because function is a constant function. When x is negative, all x is positive. So, it is a continuous function, except at 0 it has a sudden jump from 2 to 0 it is coming. So, that left and right limit differs. Therefore, it is discontinuous at a point x is 0. Okay, so that the function is discontinuous f x defined as 1 by x sine of 1 by x square, x is different from 0 and 0 is discontinuous at x equal to 0. So, in fact, we have to show the function is discontinuous. So, discontinuous means it has a different values along a different path, or if the values of the function when x approaches to certain path differs from the value of the function at the point 0, then also it is discontinuous. So, let us see the path. Choose x n h 1 over under root 2 n pi plus pi by 2. Now, you see n is a natural number. Now, we wanted the discontinuity of the function at a point 0. We wanted to show the function is discontinuous at 0. It means, we have to choose the path which approaches to 0, either from right hand side or from the left hand side. Here the path I am taking from the right hand side, this is the x n, because x n when n approaches to infinity, it goes to 0, it goes to 0. So, over this path, what is the behavior of the function? So, what is the f of x n? The f of x n in this part, because the function f is defined like this, 1 by x sin 1 by x square. So, replace this is 1 by x n sin 1 by x n square, sin of 1 by x n square. This is our, so this will be equal to under root 2 n pi plus pi by 2 into sin of 2 n pi plus pi by 2, but this is equal to under root 2 n pi plus pi by 2 into cosine of, sorry, this is sin 2 n pi means sin pi by 2, sin pi by 2, and sin pi by 2 is 1. So, basically it comes out to be 2 n pi plus pi by 2. Now, as n tends to infinity, x n goes to 0, but f of x n does not go to 0, it goes to infinity basically. Therefore, f is discontinuous at x equal to 0, and that is okay. Now, another interesting example is, find the points of discontinuities. Discontinuity of the function f x which is defined in terms of the limiting value of this function, limit as n tends to infinity, limit c tends to 0, sin to the power 4 factorial n into pi x divided by sin to the power 4 factorial n into pi x plus c square, where x belongs to R. So, we wanted to know what is that, what are the points of discontinuities. Okay. So, let us take this point, say here, yes. So, if we look this function, solution is, let x belongs to R be a rational number, be a rational point. So, first let us see what is the behavior of the function at the rational point. Now, choose n sufficiently large so that factorial n into x is an integer. Now, this is possible when x is a rational point, then we can multiply x by integer by factorial n, so that factorial n into x becomes integer after certain stage, say 1 by say 2 by 5, then I can make it factorial n say 3, so that it becomes 3 or factorial 5, it becomes the integers. So, we can always get the value of n so large, so that factorial n into x is an integer. Once it is integer, what is therefore, what is the value of this factorial n into pi x? Factorial n into x is an integer, sin of m pi, where m is integer, and integral multiple of pi, sin of integral multiple by is always be 0. Therefore, the function f x will be identically 0 for x belongs to R, which is rational number. Now, if x is irrational, then in that case the value of this sin pi will lie between sin to the power 4 factorial n pi x. Because it is irrational number, we cannot identify any n, so that factorial n into x becomes integer. It will not be possible, therefore, it will be a fractional or something else. Therefore, the value of this cannot be 0, but it will definitely lie between 0 and 1. So, the f x, which is defined as the limit n tends to infinity, limit c tends to 0, this number if I divide by this, this is 1 over 1 plus c square by sin to the power 4 factorial n pi x, thus divide by this number. So, what is the limit? This is non-zero, lying between 0 and 1, c tends to 0. So, this limit comes out to be 1. Therefore, okay, this comes out to be 1. Okay. This comes out. I will repeat again, because it is disturbed by the page. Okay. So, x belongs to rational point, then the value of the function is coming to be 0, because of the factorial n into x becomes integer when n is sufficiently large. But when x is rational number, this factorial n into x cannot be an integer. Therefore, this value cannot be 0, it always lie between 0 and 1. Therefore, limit of this, when you divide by the function limit of this comes out to 1. So, we get f x equal to 0 when x is rational, n equal to 1 when x is irrational. This is our, and this function we have seen limit does not exist anywhere, is it not? The limit, and we for this function limit of the function f x, and for this function we have seen the limit of this function f x when x tends to a does not exist when a belongs to any real number. This way it means this function is a discontinuous function at every x belongs to R. So, this is what we get it. So, it is very interesting example in the sense for that. Okay. Now, last example just we will see, find limit of this x tends to infinity under root x minus x over under root x plus x. This is equal to limit x by tends to infinity, put x equal to 1 by y. So, y tends to 0, 1 over under root y minus 1 by y divide by 1 over root y plus 1 by y, and if we simplify it, limit y tends to 0, this will come out to be the under root y minus 1, under root y plus 1 and 1. So, easily it can be computed. Thank you very much. Thanks.